the goal of this particular talk I actually wanted to give was, what is the, when we are building these AI systems, when we are actually building them in the lab versus deploying them in the wild, how are they actually performing, and also at the same time as computer science, developers, coders, and also, those of you who might be going to industry for careers, what are the lessons that you guys are gonna take from this particular talk? So I'm just gonna start with this aspect of the promise and the pursuit. I'm sure all of you guys use generative AI systems left, right, center. Anybody didn't use generative AI systems? Like ChatGPT, Gemini, I'm sure all of us, right? So it's kind of becoming part and parcel of our lives, but also at the same time, they are kind of promising something. And but what is the pursuit that we are actually pursuing or aiming for? So whenever we are building these models, and essentially when I'm talking about these models, I'm focusing more on AI ML models here. And when we are building these models, what are we typically aiming for? So when you are building, let's say, how many of you built any machine learning models or AI models in this room? What's that?
You said from scratch.
So yeah, build AI models. At least like basic classifiers, let's say. Did you guys build any classifiers? Kind of, like, right? So for example, maybe, let's say simplest, maybe something like decision trees or random forests, right? So essentially when you are building these models, what exactly are you looking for?
A goal, like setting a goal for them and then getting them to learn and like improve the performance towards that goal.
Right. So how do you define that goal in a metric way, in a metric fashion? So essentially, yeah.
You have like a desired outcome, and then you define like these set of actions that the agent or like the AI can take,
right.
And then define like when the AI does the wrong thing, you have some sort of feedback or like something.
Right. Right. So let's say if I narrow it down further, essentially we use metrics such as precision recall, F measure, accuracy scores, when it comes to LLMs, blue score, all sorts of things, right? So we do have some benchmarking data sets where we actually build our model and then see what, let's say for example, simple accuracy scores. So what is accuracy score? Just FYI, accuracy score is nothing but when you are taking the training data set. So again, I'm not going into ML lecture, but depending on, let's say, how many of our samples you have, let's say you have 100 samples, and out of these 100, let's say you correctly identified true positives and true negatives, let's say 80% of them. So accuracy score is essentially nothing but 0.8. And the best accuracy score that you are looking for is 1 meaning 100%. On all the samples, your algorithm actually performed excellently, So again, just to refresh your memory, there are 4 main aspects in the context of machine learning models: true positives, true negatives, false positives, false negatives, right? So essentially, we are looking for minimizing the false positives and false negatives and ensuring that we have as many true positives and true negatives. So in the context of benchmarking data sets, so we essentially deploy these models and they are working great. But when you have to release them in the world, meaning, let's say so it's kind of like, let's say training error, testing error. So training error, let's say you are deploying that in the model, in the lab with a very toy data set, whatnot, and then you are deploying that in the wild where you have massive new types of data that's coming up. So there is some sort of a mismatch. So again, I'm not going into much details, but there's like these errors called overfitting, underfitting, and all these things. So when you come to this particular context, the models are promising something, but while pursuing them, they are actually going crazy because they are not performing well in the wild. So so my research, again, focuses on 4 main aspects. Essentially, like I said, even though I'm in the management school, my entire training is actually in computer science. But much of my research, I do work on HCI kind of problems. So that's why it's very interdisciplinary, where I build these models to actually study how they actually are perceived by humans in multiple contexts. So at this moment, I primarily work on 4 areas. One is prompt engineering or prompting in Gen AI. So essentially, various projects that are focusing on how prompting actually influences the quality of, let's say, synthetic data generation, and what are the repercussions if the data generation is actually having these aspects of imbalanced data sets. Or the other prompt engineering problem that I'm currently working on with my students is essentially, can we make these systems more empathetic? So empathy is one aspect that I'm very interested in, and how do we, I mean, of course, there are a lot of projects coming up in terms of how we can actually generate these systems to be more empathetic. So maybe let me actually pause here and ask you guys a question. So what actually makes these systems different from us? Let's say Gemini, ChatGPT, whatever it is. How are those systems different from us? Actually, we missed asking you, are you guys students as well, or are you working in the industry? Okay, what's your majors? Computer science, okay, awesome. Okay, so how are these systems different from us?
They can't really reason.
Exactly, reason, right? So why do you think they don't reason?
Because they're just trying to mimic the output, or like the correct way of doing things. Mm-hmm. So yeah, even like when they're like in these like new AI model agents, when they do reason and they explain their chain of reasonings, mm-hmm. they kind of mimic what a human would think. Mm-hmm. So yeah.
Okay. Yes, please.
Yeah, I mean, that's pretty much it.
Okay. I think you. Yeah, you were raising your hand. No? Oh, sorry. So what makes these systems different from us? I mean, reasoning is one aspect, and also acting in a way according to the situation, right? So for example, I'm in a very professional setting right now, but let's say if I'm starting to scream at you guys, just a silly example, that doesn't make any sense, right? Because it's not in context and it doesn't make any sense. So there is this thing called sense making, where we are more adaptable in terms of different environments where these systems are not yet adaptable. So that's the entire goal. I think companies are trying to, are in this chase where who is going to meet that goal first. So I'm sure all of you heard about this AGI, artificial general intelligence, where they want to be as good as humans. But again, I think humans are very complicated. So that's one aspect that I'm very interested in, and I'm working on it. So metacognition with respect to these systems. So these systems, let's say especially large language models, they don't have these metacognitive abilities in terms of acting in the context of a particular environment. So professional versus, let's say, informal versus various aspects. So how are these systems, can they behave in a way? So also the other thing I'm also working on is, right now, if you look at these Gen AI systems, they are actually multi-turn, but it's only mainly one-on-one. But if we were to deploy these on platforms, let's say, such as Slack, where we have multiple users, let's say we all are working on a project and we all are employees, and we are just chatting on this Slack channel. And we have this system that we are trying to develop, and this Gen AI chatbot, and now it has to engage with multiple users in a multi-turn scenario. So for example, let's say I say something and somebody else, what's your name? Sorry. William. What's that? William. Yeah, William. William. Oh, William. Okay. So William says immediately some other response, but something very different in terms of this discourse going on. And let's say another friend says something completely different. So we three are talking in the context of 3 different topics, and then there is this chatbot. So for us humans, it's very easy for us to respond in such a way that maybe we might pick something that's actually more closer to us, and whoever is more chatty, maybe the first one to respond and so on. But let's say if this chatbot is there and it's also acting as another user, how are we going to train that system to actually behave to whom and also in an appropriate fashion. So this appropriateness is very important in the context of LLMs. So that's what the entire set of projects associated with metacognition is associated with. And then I also look at user privacy. And there is this famous privacy paradox which actually, we all actually think that our privacy is very important, but when it comes to convenience, we all just throw privacy out of window. And there are several studies that actually looked at this aspect, and in the context of generative AI, we are looking at how individuals, let's say I'm your instructor and you guys are in the class, and let's say William has a question, but he's too shy to ask, and so maybe he has his chatbot buddy that he can ask. So there is this context of how much information are you going to willing to share to these systems rather than asking another individual or a friend, and how comfortable are users interested in information sharing in the context of these private information spaces. And I also look at public health problems. So again, mental health is one main aspect that I study. And essentially, there are these social chatbots such as Character AI, Talkie, where you can actually create your own version of, avatar, and then you can actually keep talking to that particular bot. And a lot of people use this, especially in the context of being lonely or trying to find a friend and so on. So essentially, we study a lot of aspects in that area. And why am I actually talking about this? So the reason why I'm sharing these is because it's actually, as a researcher, it excites me that there's so much to do, and the race is not done yet. So, welcome to the world, and soon you guys are gonna be our future, and you are the ones who are gonna build these systems. So, hope my talk actually will inspire you guys to actually think about some of these key contexts and aspects that many a times we kind of ignore them and just focus on these accuracy scores or these kinds of nuanced definitions in terms of how these systems are actually performing. So let me just give you guys an example from my own research. So I talked about prompting and prompt engineering and how we can actually invoke empathy in the way that these prompts can actually help these LLMs to actually generate appropriately. So I work one of the key projects that I am currently focusing on is on actually raising funds, and especially GoFundMe platforms, platforms such as GoFundMe, where individuals are actually trying to raise money. And according to, you have to follow certain templates. So you have a description, you may put some images, and you keep giving updates, and you have a fundraising goal. And the questions that we are asking is, what actually makes people to donate to these kinds of campaigns? And how do emotions actually written in these texts play a role in terms of individuals contributing to these campaigns and so on? So one question we were interested in is, okay, so let me think that LLM is a user who is actually donating money to this particular campaign. How do they actually, whether do they contribute to this particular financial campaign or not? And in context of that, so we took different images that are posted on GoFundMe campaigns, and we wanted to see how the responses are being generated from the LLMs in terms of those captions being empathetic. So first of all, we started with baseline captions saying okay, respond to this particular user's message or respond to this particular image. And the next prompt will be something, respond more empathetically to this particular user's message. And the third thing is this nurse framework. So nurse framework is a framework that a lot of counselors and psychologists use apparently when they are actually talking with individuals in these closed spaces where they are actually trying to counsel individuals when they are going through mental health challenges. So essentially, it's kind of the naming, understanding, respecting, supporting, and exploring. So using this particular framework, can you actually generate a user caption for this particular image? And then we also, again, change the prompt in such a way that we nudge the system to not only use nurse framework, but also use some sort of a persona and then generate the response. And then in the fifth context, we actually give nurse framework, persona, and also provide some sort of a context to see among these 5 different ways of prompting, which prompting actually helps LLM to generate a better caption. In our experiment, we are using image caption generation, and which captions are actually more empathetic. And we actually, we were confused with that because, I mean, I'm so sorry, I teach visualization, and this is actually a terrible visualization, I guess, but anyway, so I don't know if you guys can read, but as we ask it to be more empathetic, sometimes we found that it's being more pretentious. You know, humans don't like being pretentious. We sometimes like to be straight. We don't want to have this flowery language, especially when there are a lot of raw emotions involved. And so we are stuck in this limbo now in terms of how do we prompt the system to be more empathetic? Because our definition of empathy is very different from the system's version of empathy. So again, coming back to the fundamental aspects of AI's model, or the mental model of AI, is very different from the mental models of humans. So how do we create these systems to be more empathetic in such a way that it actually is useful for humans rather than, you know, us building technology for the sake of building technology? So, and much of my research, again, it focuses on text, so a lot of NLP, natural language processing, and of course, text is extremely complex, even for us humans, right? So I was actually, while preparing this talk, I actually wanted to just play around and see if I can find something interesting in the context of text. And I went to the bank and then went home, overall a good day, what is bank referring to? In my mind, while I was typing that, I was thinking about riverbank or some sort of a beach, you know. And I didn't give anything in the context of, you know, while prompting this, but I just gave this, and it says, in that context, bank almost certainly refers to a financial institution. But in reality, that's not what was on my mind. And so I mean, again, I knew these kinds of things that may, but again, I wanted to show how complex text is. And all of us have different backgrounds. We are from different cultures, different environments. So, but these LLMs are actually being built for doing something very similar to in every context. But again, that context is very important. So the question that I'm asking is, for us being so different and diverse, and all of us are very different, we have unique tastes. So how can we make these systems to be more in tune with what we need and what we are interested in? So that's the question, that's the big question that I'm going to bring again and again in this particular talk. So that's where I'm going to start with the reality of wild, where these machine learning models or AI models, again, a lot of people use these terms interchangeably, but again, these models behave in a certain way, and once we deploy them in the real world scenarios, they actually completely behave extremely different. So the main question that I'm asking again is, how can we make these models to be more in tune with what humans perceive and humans like, and how can they make these models in such a way they can help our lives more, get better. So the first lesson that I actually learned through my research, again, I'm happy to share my citations. So this is one of the papers that we wrote, I mean, in the context of CS literature, I'm sure all of you know 2021 is actually pretty old, but so this paper actually what we did was we looked at different kinds of images, and we used different types of GANs, and we asked the system that we built, okay, now after looking at all these images from a particular setting, so we actually collected images from across the US, from different universities, and we asked them to generate the image of a professor. I'm sure all of you actually might have played with, you know, different LLMs and or Gen AI systems. And then this example that I'm showing here is actually from Snapchat filters. So what we did was, okay, so given an image of different types of faces, use a Snapchat filter in such a way that it can make me more pretty. So it's very interesting. I mean, again, you may not be able to see it very clearly, but over the several experiments, we noticed that there is only like one particular type of face that, you know, these systems are actually more interested in or actually more aware of. So every image is kind of being converted into that kind of representative image. So the question there is, that's actually not good, because, you know, all of us have different interests and all of us look very differently, and only looking in a certain way is not the norm. So that's where this particular lesson that I have learned is data actually lives and it breathes and it changes. So essentially these AI systems that we are building also should adapt to these changes that are there in the data sets, right? So for example, I mean, as we notice, there's more globalization happening all over the world, and the systems that were trained on one kind of data may not be applicable for every kinds of data. So that's where this particular lesson is coming from, where as the data keeps changing, the model's results are also changing, which actually should not be the way. Because if you look at many of these real world systems, in case you don't know, many of criminal justice systems use machine learning models to figure out, let's say if a person comes in, gets incarcerated, how much sentence should they give or should they get? So they use these systems to essentially figure out maybe approximately this much, this many number of years. Is that actually, I mean, is that fair? You know, so those are the contexts that we have to think about. And also, of course, I mean, I'm sure you might already know, in the context of hospitals, especially in the radiology department, when you get a scan, before the scan goes to a radiologist, the system actually tells what kinds of aspects are seen through the scan and whatnot. And again, there are some very ethical issues in that context in terms of course, there are like false positives, false negatives, but how do you handle them as a radiologist? So that's the other thing. There is a big mismatch between how these systems have been trained and how humans are actually being trained. So how do we fill these gaps is, again, the main context here. So my key response to this particular lesson one is continuously maintaining and retraining these systems in such a way that they actually are aware of these kinds of data-related challenges, because a lot of times people talk about biases. And again, that's a big debatable topic, and I'm not going to get into those details. But personally, of course, these systems are being trained on a certain kinds of data. So obviously, when the responses or the results come in, the biases in data will reflect. So how do we identify them, and how do we mitigate them? And the lesson two, through my research, I learned that users don't behave like data sets. I mean, even though we collect data from many, different examples, exercises, but unfortunately, we don't behave like these nicely curated data sets, because, our interests, our ways of living, and our cultures are extremely difficult. I'm so sorry for putting this image, but I mean, I just wanted to show the raw reality of where we are. So in fact, I actually made sure that I have these outputs fresh. And so I asked Gemini, okay, generate 6 faces of pretty women, and the other side, generate face of 6 ugly women. I was like very surprised, because again, beauty, again, I don't want to get into those things, but here, if you look at this particular left side image, it's like everybody has some sort of like very similar characters, like short noses, different types of very curated, like nicely done hair, whatnot. And it's like, so again, the main point that I wanted to bring up in this context is we don't behave this way, right? Our definitions of beauty might be different, but these systems actually have these way of identifying what beauty is, what the definition of beauty is. So what I'm trying to focus on from this particular lesson too is we have to have some sort of feedback, and also do some sort of user experience studies, and also focus on explainability. Whenever these systems are generating these kinds of responses, so it has to be explainable. And why is it generating that? Why is it saying that this particular image is beautiful or ugly? I mean, again, all these definitions are kind of very blurred. So coming back to the main message of this particular talk is, how do we make these systems in such a way that they are in tune with what humans want, and how they can actually improve our lives. And the third lesson that I found out from my research again is ethics and empathy in the context of evaluating these systems could be used as some sort of debugging tools, actually. I don't know how many of you guys know this latest story from, I don't know where exactly this student is from, but this is a teenager, and this was from New York Times. So this teenager was actually, again, TMI, if you get triggered, please leave the room. But this is a very sad story. So the student already was pretty suicidal, and ChatGPT actually was kind of being his buddy. And when the teenager was actually telling ChatGPT, okay, I'm going to commit suicide, I'm making knots to actually hang myself. And ChatGPT was like, yeah, you are doing great. This is a perfect knot, whatnot. And actually this person committed suicide, and now their parents are actually in the court asking these companies to be more focused on these kinds of things. So of course, I'm sure all of you, how many of you actually, when you are interacting with ChatGPT, might have noticed where it just keeps kind of saying yes to everything that you say, right? Even if you say, oh, what you did was wrong, even though the response was correct, it actually says, oh yeah, you are right, this is actually wrong. So is this good? Everything that we are interacting with these systems, it's like kind of making us happy, but in reality, is this actually good, and where do these systems need to draw the line? So again, there's a lot of literature in the context of jailbreaking these systems and how you can actually use these systems to behave in a bad way and whatnot. So the lesson that we are trying to, that I'm learning here is ethics and empathy actually can be used as debugging tools. So when we are evaluating these systems, you don't necessarily have to rely on just these metrics such as precision recall, F measure, whatnot, but also using these metrics such as like empathy and ethics are very important. And actually they might help understand where these systems are actually failing and so on. And the fourth thing, lesson that I'm learning is, as I said in the beginning of my talk, I actually, I enjoy working in teams and also like meeting multidisciplinary researchers, a team of multidisciplinary researchers, and essentially you guys are our future. You are the ones who are gonna go out and build these systems. So I would highly encourage you guys to think about how do you, while you are building codes and while you are building these systems, I think it's a very important thing for us to keep in mind to actually collaborate with people who know the domain knowledge. And that's where we are going to actually make progress is my key takeaway. Where deployment is essentially a teamwork. It's not just an individual work, and we have to put our minds together. So this is an example from, I think, so Google actually works closely with many university campuses, and this example is from Stanford's medical school, where they are actually trying to leverage Gen AI to answer different healthcare problems and so on. And I just put that, I'm sure many of you know NotebookLM, right? So do you guys know NotebookLM? So just wanted to see, kind of summarizing what exactly this particular article is talking about. And as you can see, if you carefully observe this, there are actually a team of not just Google developers and computer scientists who are involved in this project, but also a lot of policymakers, legal experts, and also ethical researchers are actually involved in this. And that's where my fourth lesson is essentially developers, designers, and domain experts all actually will be a key, playing a key role when you are actually shaping the success of these generative AI or AI systems. So with that, I will actually focus on the view of the future, where for designers and developers, you guys, while, right now you guys are students, but when you go out in the industry, designing these AI/ML systems that are actually resilient and also human-centered, focus is actually one of the main things that I want you guys to keep in mind. And right now, you are on campus, and I want you guys, also if there are any educators, to care about both precision and also actually perception. Precision meaning like these kinds of defined metrics are good, but also how these actually systems are behaving in terms of meeting the human needs is also very important. So with that, I'm going to conclude my talk, where the best AI isn't just built, but it's lived, learned, and iterated with humans in the loop. So that component of humans in the loop is very important. And as developers, I would say that you are not just coders, but also deployers of culture, responsibility, and intelligence. So with that, I'm going to end my talk. So thank you so much, guys. And again, if you are on campus, I mean, I'm in Pittsburgh building. Please stop by. And I also take I work with a lot of undergraduate students. So if you want to work on a URP project, sorry, shameless plug, but just stop by, and I would love to meet with you guys. Thank you again for your time. And yeah.